Hello and welcome to the Rubber Duck Dev Show. I'm Chris,
I'm Kristen.
and tonight we talk about Ruby fibers, not just for digestion anymore. So this Ruby fibers aren't a new thing, but they're getting more and more use lately since Ruby 3. I understand. I don't mess with them much, so Guru over here is going to teach us. But before we get into all that fun stuff, how was your week?
Well, I should say I am not a guru on this stuff because I had to research it. It's just basically this different stuff that came out with Ruby 3. I'm like, all right, I'm going to spend some time to kind of know it, understand what it is, what the implications are, the impact. So that's why I'm kind of been covering the different stuff with Ruby 3.
Yep.
So I'll just impart what I've discovered. So in terms of this week, it's basically same old Rails consulting, PostgreSQL database consulting, and working on my product. So that's pretty much it. I found some interesting things out with regard to Ruby that I actually put in the tail end of the presentation. So something I discovered. So stay tuned till after the fibers if you want to learn more about that. But I will say, in some of my consulting, one nugget that I will present in case people have encountered this, but when you're running the Postgres database and you're doing inserts, a lot of people have tons of sidekick jobs that try to insert data into the database. And sometimes you run into, maybe you'll call it a race condition, but you can easily handle it because like sidekick jobs recover from failure, where you're trying to do an insert of a value into a table. And you may have multiple workers that are trying to insert the same value, and you get a constraint violation. Like maybe you only want a particular unique value in the database, and you get an error, a unique constraint violation. Well, that of course gets logged. Now, actually, sometimes if these go rogue, you can have your log filling up quite quickly with all of these messages. But there is a way that you can handle them without logging, and it actually doesn't impact a lot of wall writes, the write ahead log, and other methods. And that is by simply adding the clause on conflict, do nothing. So a lot of people use on conflict, do update. So they try to insert something. If it fails, do the update. But if you want it to have a failure state, you can simply say, well, do nothing. And in that case, it's not going to log anything. And it also saves on logging things to the write ahead log and some different places. So just a little nugget that I thought I'd share with the show,
Nice.
that if you're running into these types of things, maybe consider doing that.
Cool.
So how was your week?
It was actually pretty good. So the big project that I spent all that time upgrading to 3.0 and going through the double splat conundrum. I got that all worked out, and once all the tests were passing for 3.0, I said, okay, let's go to 3.1 now. So I upgraded to 3.1.2, and that was surprisingly easy. I had to update a couple of gems. Now we're still on Rails 6. So we have to upgrade that, but we wanted to get the Ruby updated first. So there were a couple of gems that needed upgrading, but not very many. I had to add a net HTTP gem because we're not at Rails 7 yet. So it's kind of a temporary gem. And once I did those things, I ran my test suite and I only had one test fail. And the reason it failed is because it was a test for an error message that included the source URL. And in the case of the test, that source URL was localhost. Well, apparently, I think this has to do with that net HTTP. Instead of logging localhost, the word localhost, it logged the actual loopback IP address. And so that test failed because it was looking for the word localhost. So we looked at the test and said, well, okay, we don't really care whether it says localhost or 127.0.0.1. So I really didn't have any failures upgrading to Ruby 3.1. So that whole process took me about 2.5 hours, 20 minutes of which was running through tests.
That's always nice.
Yeah. Um, so that was a nice surprise. Um,
Because I did a test upgrade to 3.1.2 and ran my tests, and I had a bunch of failures. So I don't know what was going. Maybe some of my gems, one of the gems somewhere is out of date, and I'm like, I ain't got time to deal with this right now. So,
yeah. Well, until I updated those gems, I had massive amounts of failures, but that's
and
because
this was a month or two ago. So
yeah,
maybe some people have released some updates to fix things. Yeah.
yeah.
So no.
So, but yeah, it was only a very few gems, and we use quite a few, more than I really would like to see, but still, it was a very few gems that I had to actually update. So that was really nice. And then there's a lot of I was doing a lot of log diving and investigation to try to try to uncover the source of a latency issue that popped up in one of our products and see if I could figure out what that was all about. And it turns out that we're going to have to do some refactoring. It's a thing that it didn't just pop up. It kind of grew up over months and months and months of changes, many versions of stuff. But we've identified some things where we might be able to make some improvements, but there are far-reaching consequences possibly, so we have to be a little careful where we tread because it's in a bit of a core area. So we have to kind of treat it as a refactor project rather than just, oh, let's just change this, because that could be extraordinarily bad. So anyway, that's been most of my exciting week, other than administrative goop.
Alrighty.
So Ruby fibers, let's talk about those.
All right. Go to the next one and go ahead and hit it. So I actually didn't know it was this far back, but they were released in Ruby 1.9, which is quite a number of years ago. And not quite sure why they were implemented. And because by fibers, you can have multiple fibers per thread, essentially, I think is why they kind of called them fibers. But they're really kind of a different animal than threads. Um, so, when you're running a process, you have, one thread running and you can choose to spawn more threads. Well, with a fiber, essentially you have one fiber running anytime within a thread, and you can create more fibers. But basically, the programmer has control as to when they run.
Right.
Now, some of the advantages of fibers is that they consume less memory than threads. So you're not creating a thread; they're a more lightweight implementation. They kind of remind me of Elixir. They have things they call processes, which are not an operating system process, but they're small, little, lightweight implementations. That kind of reminds me of that.
Yeah.
So the next bullet. So they can be paused and resumed by the programmer. So you have control as opposed to the operating system's thread scheduler. Now, because of this, there's less context switching, say, between cores. Because at any time, oops, sorry here.
Here, I'll fix you.
You fixed me. Thank you. So at any time, threads can be interrupted by like I said, the OS thread scheduler and transferred to another core, for example, or it runs another process. And therein lies the problem with race conditions when doing multi-threaded programming, is that say you have thread A and thread B. In thread A, you say, okay, read this value, and then I want you to write and update it to increment it by 1. Well, say you've read it, and now suddenly the thread scheduler says, okay, time for thread B to run. And it never wrote anything. And then thread B says, okay, read this value, and I'm going to write +1 to it. And it writes +1. Or write something else to that value. And then you go back to the thread scheduler. Okay, thread A, you can go ahead and now it's going to write what it intended to, but it is essentially going to overwrite what thread B wrote. So it's a race condition essentially.
Yeah.
And basically fibers, you can, avoid that kind of situation because you control when things switch. All right. All right. So this is a bunch of code, but like 1 to 23 is actually the code, and then the results are 25 on down. And this is using fibers, and this is a variation of what Ruby has put out for, hey, here's how you use some fibers. And basically what this code does, the begin and end is just in a console. I can just paste it and it just runs without doing things. So you can ignore that. But line 2 is just says start the program. So you'll see the output below of that. And then it creates on line 4, we're creating a fiber and we're putting this work into the fiber, but nothing gets run yet because, and then it sleeps for 1 second on line 13. And then you'll see puts 2. So that's the second line that's put out. Nothing from the fibers put out. So you can see in the output on line 26, that's 2. And what it's said is resume the fiber the first time. And you can see that the seconds have gone from 27 to 28. So essentially, the only thing that's actually run in the main thread is or processed is line 13 sleeping for a second, and then 14 putting that out. Line 15 resumes the fiber, but in this case, it's essentially starts it. So now you can see it entered the fiber, slept 1 second, and then it's going to yield back to the main. So the fiber yield means it's going to stop processing that fiber. Control passes back to the main line, and then it says, okay, resume fiber the second time. It'll resume it, and now we'll go back, continue running from that yield point within the fiber. And you could have multiple yields, as many as you want to within the fiber, to bounce around and kind of do what you need to do and give yield control back to the main line processing as you were.
One of the things I
But
really like
go ahead.
about this is the fact that dot resume is also start. So you don't have to do a bunch of, hey, is this already running? Is it paused? Should I resume it or should I start it? And all that crap. So this is a lot better than normal thread programming in most languages.
Yeah, so it's, again, it's pretty easy to use, and you can kind of have been doing this since Ruby 1.9. But the significance is what came with Ruby 3. So if you go to the next slide. So basically, they introduced a fiber scheduler. So it's a way of doing an implementation where, as long as you follow a standard, you can build a scheduler to schedule fibers together. And this gets really interesting when you start doing fibers for using it for non-blocking IO. Because like we talked about in the Ractor presentation from a couple of weeks ago, a lot of you can get a lot of concurrency benefits just by doing other things while things are waiting for IO. So when you're waiting for a file to download, or you're writing to a file, or you're writing to disk, or reading from disks, or accessing a service, you can, well, a lot of people use threads for that. So they put it in a thread to do that work and wait till it comes back. You could be using fibers instead, or in the future, maybe you could use Ractors. Now, there's nothing fancy. There's still only one fiber that can run per thread at one time. If you go to the next point. But kind of how the way it works is that one fiber starts an IO task and can give up control while it's waiting for that IO to be done. And really, what you would have to do manually previously of saying, okay, pause here, yield here, okay, now resume again and yield. Basically, the fiber scheduler takes care of handling some of that resuming and yielding of the fibers so that you can coordinate a bunch of fibers to download things in seemingly in parallel, or accessing services in parallel, etc. So it's kind of the fiber schedule introduced in 3 that kind of has made this a little bit easier. And probably the easiest way to get started with using async IO is the async gem. And I said, you can see here it says it's the easy button, I would call it.
I like those.
So the async gem's been around a while, but I think they recently refactored it to start using in Ruby 3 to start using the fiber scheduler. So basically it's an asynchronous IO framework. So a way for you to spin up, like they're purporting, thousands of clients or essentially thousands of fibers per process. And basically it can do all these IO callbacks, not callbacks because there are no callbacks, but do all these IO operations seemingly in parallel with one Ruby process. So you don't have to do multi-threaded programming. So if all you have are IO delays, you can simply use this and not worry about multi-threaded programming. So this is pretty easy. Has the async gem requiring async, and we're going to be doing net calls of basically sending to Google a search. So we're sending 3 searches on line 8, Ruby, Rails, and async. And again, this comes from the Ruby 3 announcement, and I just put some variations in here to kind of make it more explicit. And in the async, basically, you put whatever work you want to do within that block. So the async block is going to call Google to get some search results. And then line 11, I'm just saying, all right, put that once you have the query. But of course, you could then parse those search results. You could write to the database. You could do whatever you want to in this async block. It's going to process it in an asynchronous manner, and you get parallel benefits if IO is going on within that asynchronous block. If it has to do actual processing, you're not going to get parallel benefits because only one fiber can run on a thread at a time. But if you are doing IO, you're going to get a lot of benefits through doing this. And then after that async block, I'm just saying print it out immediately for each of these. So when the output on line 17, you could see it immediately outputs that immediate puts call. Because again, the async, it's not waiting for anything, it's just run, boom. But then the async block continues to work after this code is run, and then you can see the different results. And you can see it happens in an indeterminate order. It's whenever those connections that were made to Google return the search results, then it returns. So you could see the last one actually done, the async immediate, the last one that was actually sent is actually the first one to return for whatever reason.
Now, with this, do I have that yield? Do I essentially have the ability here? So in the middle of that async, or when I pop off that async, can I make it so that, hey, this has to finish before you can continue on here?
Well, at this point, you could have, and maybe I'm,
So let's say I've got this scenario, right? I've got to pop off A, B, and C, right? So A
yeah,
pops off B and C in the threads or
yep.
in the fibers. And then A does a few more things, but it gets to a certain point and I need it to make sure that B and C are done before it goes any further. So do all this stuff, but then pause until these are complete. So because that's something I routinely had to do when I was doing thread programming in .NET. Yes, I can go do a bunch of stuff, but at a certain point, I have to make sure that these are done so I know what they did to carry on.
The answer is, unfortunately for you and others who are interested, I don't know. But I know there's a lot of features in the async library. So I would probably look at the async gem documentation, and I can take a look at it if there's a break or whatever. But there's a lot of capabilities they built into it. And I guess I wouldn't be surprised if that capability somehow exists.
Yeah, I'm
Because again, this is just a very simple representation of it.
sure. And I know there are ways to force that kind of thing with, wait loops and semaphore files and that kind of stuff, but it'd be nice if
Yeah,
they
but
had
this is
some
just kind
built-in
of an
way.
easier way to do an implementation, where you don't have to use threads.
Right.
So So that's pretty much it for the fiber presentation, kind of what they
It's
are.
yeah, it's not
And
complex.
no, um, again, most of my interest is in the Raptors given its capabilities. Um, but there's some definite, seemingly some definite interest in fibers. And if you're needing to do like parallel IO related tasks, I would probably like if I have to do some type of parallel IO related task or contacting services in parallel for something, I would probably grab an async gem and see what its capabilities are first versus trying to do something multi-threaded.
Yeah.
But that's and based upon my research, that's what I'm kind of that is what I would investigate first.
So yeah, chat.
But
If you have any ideas about that question I asked about, can you ensure that these sub processes have finished in separate threads with the async gem or fibers, if there's a standardized way to do that, because I just haven't looked into it. I would be curious to know if you guys have answers or best practices for that kind of thing. Please put them in the comments. We do like to learn too, so feel free to do that. All right, so another little bonus content section.
okay, here's something. There is a headline on the GitHub called for the async gem called waiting for results. And it says, quote, like promises, there is the async task module produces results. In order to wait for these results, you must invoke async task wait. So it looks like there's the capability where you can introduce a wait at some point in your code. Like, for
Perfect.
example, if you go back for a second. Yeah, so the implementation would be you would actually set a variable for like line 9 maybe, or maybe before that says task equals async do, and then below you could put task.wait, and it'll wait for those to be complete, is my understanding how it works.
That sounds like exactly what I was looking for.
Oh, but then they have talking about semaphore wait, waiting for multiple tasks, but I don't know if they're part of separate. So they are invoking the use of barriers and semaphores. So definitely look over the
Yeah.
if you're before you use it, of course, look over the documentation for the gem.
Yeah, for sure.
But it does a lot of stuff for you.
Cool.
All right. So and like I mentioned, as part of my consulting, um, had a client who was tracking basically there's a lot of IP addresses they needed to keep track of and know if a certain IP address exists within a big set or a big list. And usually when dealing with collections of things in Ruby, I typically use arrays or hashes. And hashes are you can think of as like indexes or lists, maybe in other programming language, basically key values pairs or whatnot. And I was looking at, and I was just thinking, I wonder when we're talking about thousands of values, because there were, I don't know if it's 30,000, 20,000, some crazy number of values. Are arrays the best thing? Because I normally don't question it because my arrays are not usually that big.
Right. Searching
But
through
for
a
this,
5-member array is not a big deal.
yeah. So this one was like, is there something that, so I started Googling, did a lot of researching, not a lot of researching, but, searching to say, hey, what are our alternatives? And there's actually something called Ruby sets, which I haven't really used. So it's basically like an array. It's just a set of values, and you can put, you know, text in it or integers, whatever. The thing that makes them different than arrays is that they are unique. So automatically they're unique because so they're kind of, you can think of them kind of like they're key based. So they're unique. And then the other property they have is that they're unordered. So like, and I don't think I don't believe there's a guarantee to promise the order. So it's basically they're just unordered. So again, it's more like a key value storage type thing, but essentially it's only keys.
Hmm.
And it gives, compared to an array, it gives O1 performance versus ON. So what that means is that almost no matter the size of the set, returning the value or checking for its existence doesn't vary that much based upon how many members are in the set. Whereas the performance for arrays is dependent upon the size because it's essentially scanning through them. So, and this is a little implementation to look at performance differences between arrays and sets. So, like line 1, you have to require set in order to use it. And in line 3, I'm saying, all right, I'm going to create a new set. That's how you create. I could do array new instead of the brackets for line 4. And I did a query for like, I don't know if it was 30,000, basically a lot of different, essentially IP addresses, stick them in the set or stick it in the array, same type of operators used. And this performance wasn't measured. I just said, just run it and just stick them all in there. And then the benchmark was they said, okay, I'm going to look for an IP address, in this case, X, that exists. So does the IP set, like on line 13, after the report part, does the IP set include the X? And X was included, or Y, it wasn't there. So I
And
could
you
have,
knew ahead of time for this test that X was included and Y was
oh
not.
yeah, because I ran it to test beforehand that X was included and Y wasn't included. Yes.
Right.
And then go ahead and ran them for the sets and the arrays, and the
Oh,
results are down
whoops.
here. And look at what I tend to look at is the real time, because that's the real clock time. And as you could see, checking if something was there was 100 times faster in a set versus an array. And it was 250 times faster if it was absent.
That's a little bit.
And I probably could
Jeez.
have done another cool thing and said, okay, well, what is it like for 100 member array versus a set? And what I think you will see is that because of that O1 versus ON, you'll see the arrays, it will vary based upon the size of the array, and then it maybe won't vary as much with the set.
Yeah, so there's a certain number where there's a tipping point where sets will make a significant difference over arrays, but before that tipping
Right. So
point,
small, right. So small things, sets are, um, it doesn't make any sense to use them. But once you're talking maybe high hundreds, thousands, then you're going to see, you know, change in performance differences such as this if you're using a set.
now are there any downsides to using sets instead of arrays?
If you care about my understanding, I didn't test this or whatever, because this particular use case is,
Speed,
was the IP address there or not? So,
right?
but my understanding is that they're unordered. So if order is important to you, like if you're doing a first in, first out queue or things like that, you can't really use a set for that, is my understanding. And
Because it
what
acts
was
more
the
like
other
a
thing?
database, an RDBMS, where it just puts the records wherever and
Kind of, yeah.
pulls
And
them out
and
however.
is the hash is the I think hashes is the same way. It's like key order has no meaning, right?
I believe so, yeah. There's no, I think you
Yeah.
can
So
make a hash ordered. There are ways to do
and
that,
if
but
you if you need duplicates in the array, it doesn't work either. But so it's only unique.
okay.
So again, they're kind of like, you can think of them as key-based arrays type thing. So as long as you don't need duplicates and you don't need order, you can use sets.
Wow, that is a huge performance difference.
And again, it's kind of like they're only keys. So in terms of storing complex data, you can store an array of objects. I don't
Right.
it wouldn't make sense, and I don't think you can store objects within a set
Okay.
type thing. Because again, they're just kind of like keys, which so you would think, but you can store strings, you can store primitives, but a complex object, I don't think that would
But
work.
if you're in the realm of numbers where sets become beneficial anyway, you're probably not wanting to instantiate all those objects to store.
True.
So, yeah, I can't see you wanting to store objects in a set. I don't typically want to store objects in arrays either, unless it's just a couple.
Yeah.
I'm usually because then I have to not only do I have to pull the information from the database, but I have to instantiate them, which takes a lot of time. And when you start putting those things inside loops, then you get massive latency problems, and it's just nasty. So I try to avoid instantiating objects as much as possible. Well, in most languages, but particularly in Ruby, if I can help it.
And the other interesting thing is that to go along with this is one way that we're potentially looking at storing something like this is within Redis. And Redis, of course, can store strings, and it can also store lists. And I would say those are more equivalent to an array, but Redis also stores sets, and they're the same type of thing. They have essentially that O1, that constant time performance for lookups. They are unordered, and I think they are unique. So essentially, they're similar implementation to Ruby. So if you have Redis, use Redis, familiar with it, eh, these give you the same benefit. So if you want to store something in Redis, you could use sets for that too.
Nice. All right.
So that was kind of an abbreviated presentation for this week, but that's what I got.
Oh no, that's fine. Um, yeah, that's good stuff. I've never used sets before. I've heard that they were out there, but I never really paid attention to them because, as you said, normally with arrays, you're not dealing with thousands of things a lot of times, but I have and never really paid attention because it never became a speed issue in those cases for me. But that's good to know about. I'm actually more excited about the bonus content tonight than the main course. But
Well, like you said, how does this help me? And again, if you already have, like you said, you have Sidekick to do stuff in parallel,
right,
and they kind of put the threading implementation behind the scenes,
yeah,
behind an easy button. So as I would say.
yeah,
So, fibers are kind of if you want to get down into the weeds or implement your own gems for doing things, making them easier,
right.
um, or the async gem if you want to do a few things. But again, you could always use, uh, Sidekick and processing multiple jobs in parallel if you want to do that kind of stuff.
Well, awesome. All right, I feel smarter already. This was a good night. All right, hope you guys enjoyed that. If you did, and you want to help out the channel, please mash that like button and consider subscribing so that you know when we go live every Wednesday night at 8 p.m. Eastern. You'll get a reminder if you choose to get reminders on YouTube. Um, just mash all the buttons and ding all the bells. Also, you can find our podcast version of this anywhere that podcasts live. You can also join us on our website at rubberduckdevshow.com, where you can find all of our videos, all of our podcasts, and you can sign up for our newsletter. You can follow us on Twitter at DuckyDevShow, where we will make announcements for various things once in a while. Let's see, what else? If you have ideas for the show, if you have topics that you'd like to see, please put them in the comments below, because we want to cover topics that you guys want to hear. So if there's something you want to hear, please let us know. Also, I've been reaching out to try to get some guests on the show, working on that, trying to work schedules out. So we should be having some guests pretty soon. We haven't picked a topic for next week yet because it's just been one of those weeks. So if you want to know what's coming up,
Isn't it one of those weeks?
right? It's always one of those weeks. But if you want to know what's coming up, follow us on Twitter, and I will try to make sure to announce that as soon as we decide it. Anyway, I had a lot of fun tonight. Hope you guys did too. We will see you next Wednesday night at 8 p.m. And until then, happy programming.
Happy programming.